Welcome back. Just like I said in the last lesson, in this lesson, we are going to be looking at list copying a list into another list. List copying can be kind of tricky to understand, and that is why I separated it into a lesson of its own. Don't let that scare you. You are going to do just fine. Let's look at this scenario. If you have two variables, let's say x and y. Okay, let's get rid of this. So we're going to put this in our reference just in case we need them later. Okay, so we're going to put it in reference. Okay, the spelling of my reference is even not correct. I have adding 2. I'm going to call this list operations 2. Okay, let's call it list operations 2. Then it's a Python code. We have our Python. Okay, actually write it in package. That does not make any difference. Operations. Okay, all right. My reference is not correct. I'm going to rename it to can use the factor, so we'll do the same thing. Yes, reference, there should be E after F, right? Not capital letter. Rename and to have a lowercase e. Right, so that's the correct spelling of reference. Mr. Mark, over here. Now, let's look at this scenario. If you have two variables, let's say x and y. So let's say x is John, okay? I'll say x is John. And then we are saying y is equal to x, all right? Now let's print both x and y. So let's print x, and then we're also going to print y. Okay, we can have the name so that... All right, so if we print that, okay, so we have x to be John and we have y to be John. What is the reason that y is equal to John? The reason is because I'm saying y is equal to x when x is also John. That means y is also going to have the same value as x, all right? Now, if you change the value of y later, let's say y is now equal to, you can say y is Jane, all right? So now we are changing the value of y. Let's print both x and y again and see what happens. So we can print x and y again after changing the value of y. So you can see now that x remains the same while the value of y has changed to Jane. Okay, so you can see now that changing y does not have any effect on x. Now let's try this with a list and see if they behave the same way. Okay, so we are going to comment all of this out. Let's try this with list and see if list is going to behave the way string is behaving now. Okay, so let's say we have a list, we can call it original list, okay, because we're going to make a copy of it, just like we made y to be a copy of x at this point. Okay, so let's say original list is equal to, let's just make it 1, 2, so we don't have to create another long list, 3, 4, and 5. All right, now let's create a copy list. Let's call it copy list. Okay, and then we are setting copy list to original list just the same way we set y to be equal to x. All right, so let's print original list, and we're also going to print copy list. All right, if we run that, Control F5, that's my shortcut. Your shortcut can be different. Okay, now you see that original list is the same as copy list. Okay, so let's have a text in front of them so that we know which is which. So that's for original list, and this is going to be for copy list. Okay, so I'm going to have a text here. I'm going to paste that with a colon. Right, now we have copy list. If we run that again, what do we have? So we have original list to be this, copy list to be this. Now let's modify the copy list and see if it has any effect on the original list. So let's say copy list dot let's append 6 to copied list. Okay, you know the original list stops at 5, and then we made the copy of the original list to the copy list by assigning copy list to the original list. Now I'm appending 6 to the copied list, just like here that we change the value of y to begin, and changing y does not have any effect on x. It doesn't change the value of x. So now let's print we've appended 6 to copied list now, Now let's print both original and the copied list. Okay. Now if we run this, let's see what we have. So you can see now that we only changed the copied list, but the original list was also affected. Just only modify copied list, whereas the modification we made to copy list is also affecting the original list. Why is that? Why is it happening? Why is it that it's not happening the same way that it happened with X and Y when we modify only Y, and the modification we made to Y does not affect X? So let's run this again. You see, by modifying Y, it does not have any effect on X. X is equal to John, it remains the same, whereas Y was changed to Jane. But here now, adding 6 to copy list, it's also affected the original list. So why is the behavior of list, why is it different from an ordinary string? The reason for this is that if you assign a list to another variable, just like we have here, just like we assign copy list to original list, both variables, they point to the same list in memory where the list is saved. So when you assign a list to another variable, you are not creating another list entirely. Both variables, both the original list and the copy list, they are pointing to the same list in memory where the list is saved. So you are not creating a new list, you are just creating a new variable. And that variable is pointing to the same list that the first variable is pointing at. So by assigning copy list to original list now, both the original list and the copy list variable, they are pointing to the same list in memory. So you are not creating another list entirely, you are just pointing both variables to the same list. So whenever you modify the list, it is going to reflect in both variables. All right. So if you want to check the reference ID of both variables, you will see that they actually have the same reference. Let's see the reference of both variables now. Let's say we want to check the reference ID of original list. So you use the ID function to check the reference of any variable. So we have ID of copy list. Okay, so let's print them. So we're going to print. Okay, then I'm going to wrap this in a print statement. I'm going to print. So let's print both IDs. I'm going to comment. Okay, let's just leave them. Okay, so you can see now that both are original lists. So this is the IDs of the original and copy list variables. So you can see now that their IDs are the same. So that is telling you that both variables, they are pointing to the same list in memory, right? So if you modify just the second variable, it is going to affect both of them because both of them are pointing to the same thing. And what they are pointing to has just been modified, which means the modification is going to reflect through both variables or as many variables that are pointing to the same thing. All right. So the solution to this problem is using the copy method. Just in case you want to make a copy of a list, but you don't want the modification on the copied list to affect the original list. So the solution to that is using the copy method. The copy method is available on every list. So you can copy items in a list to another list in Python using the copy method or using the slice method. The copy method is going to create a shallow copy of the list. We will talk about what shallow copy means in a second, but let's first use the copy method. Okay, now that we have the original list, we can comment all this out. Okay, so let's comment all this out. We have the original list to be 1, 2, 3, 4, and 5. Or we can as well copy this line and comment it out as well so that we have everything in the same view here. Okay, so using the copy method now, we are going to say copy list. So we are going to have original list dot copy. All right. So now if you make changes to copy list, it is not going to affect the original list. Okay, so let's say copy list dot append. Now let's append 6 to copied list, and now let's print both original list and the copy list. We are going to see now that the original list remains the same. Let's also comment all this out. Okay, so you can see now that this is original list, it stops at 5. Okay, and now we have copied list and it stops at 6. You can also use slicing. You can use list slicing to achieve the same result. To do that, let's comment this copy list out. So to use list slicing, you can say copy list. Okay, we have list to be equal to, so we're going to have original list, and then we have to copy everything, let's just have a colon, so we are not providing start and end. Okay, so that's going to copy the original list. It's going to create a shallow copy. We talk about what shallow copy means in a second, right? So let's run this now. You can see now that also this slicing method does not affect the original list, right? So the copy method has solved the problem we initially encountered with list. Now let's see what shallow copy means. To understand what shallow copy means, let's say we are dealing with nested list, which means a list that contains another list. Okay, let's comment all this out so that we explain what shallow copy mean, right? We can as well minimize this. Let's say we have original list, which is a nested list. When you have anything nested, that means one is inside of another. So let's say we have a list that contains other lists. So we are going to have another list. Let's say this list consists of spoon, right? And then we have another list. Okay, so let's say this one consists of, plates. So this original list now is a nested list because it is a list that is containing other lists. This is one list, this is another list, right? Now let's create a copy list. So let's say we can have copied list is equal to, so we're going to say original list dot copy. All right, to see what we are dealing with, we can print both original and copied list. Okay, so let's print copied as well. If we run this now, okay, so you see that the copy method has made a copy of the original list into the copied list. Now let's modify the first item in the copied list. Now we are going to say, let's modify the first item. You know the first item is also a list, so we can say copied list. So the first item is going to have an index of 0. Now the first item is a list on its own, so we can append, let's say we want to append the spatula, right? Okay, now we are modifying the first item in the copied list. You see, this is the copied list. Now we are appending spatula to the first item. If we run this now, let's now print both original list and copied list. So we have original list and then we have a copied list, right? So if we run this now you can see that by modifying the copied list, it is also affecting the original list. This is original list now, and this is copied list. If you want to see that, we can add. So let's say this is original. Okay. And then this is our copied. So I'm just going to say CO to signify copy, right? So if we run this now, you see now that by modifying the copied list, it is also affecting the original list, which is different from the behavior that we got here. You know, here when we modify the copied list at this point, it does not affect the original list. But at this point now, by modifying the copied list, it is also affecting the original list. Why is this? This is where the concept of shallow copying comes into play. When you are dealing with compound list like a nested list, a list that is containing other list, the copy method, it creates a shallow copy, which means when copying a nested list, the sublists that are inside of the original list are not recreated newly into the copied list. Rather, they are only referenced, which means it is the same sublist that is filling both the original list and the copied list. Lists are designed to behave like this in order to manage memory usage better. And this is not only peculiar to Python, it is also the same with other programming languages. Now, being that both the original and the copied list are referencing the same sublist, if you modify the copied list, it is also going to affect the original list because they are referencing the same content. The solution to this problem is using the deep copy function. The deep copy function, it deeply copies the original list into the new list. It constructs an entirely new list from the original list. Therefore, modifying one list does not affect the other. The deep copy method is not available on list. It is only available in the copy module. So to use the deep copy method, we need to import the copy module first, and then we access the deep copy function from it, right? So we are going to import the copy module. Don't worry about details of module and importing. We'll to that in later section, right? Just know that to use the deep copy method for now, we need to import the copy module. Okay, so now to create a deep copy, we can use the deep copy function on the copy module. All right, so this is our original list. Now let's comment this out. Let's comment all this. Okay, so we can also comment this. So we are going to copy the original list so that we have everything we are working with in the same view. Okay, so now we can have copied list. Copied list is going to be equal to, so we are going to have copy module, which is what we just imported at the top of our file. So we are going to have copy.deep copy. Okay, we are going to have deep copy. Then we are going to provide the original list we want to copy. Okay, so we provide the original list. Now this deep copy method is going to create a deep copy of the original list, such that if you modify the new list, it is not going to affect the original list. This is only needed for complex list, like a list that is containing another list. If it is just a plain list, a single dimension list that does not contain other list, the copy method is enough for it. But for complex list, to have a deep copy, you have to use the deep copy function that is available in the copy module. All right, so let's do the same operation now. Okay, so I'm going to copy this. I'm going to come here. All right, so I'm going to do this, and then I'm going to print this again, so that you see that modifying the copy list is not affecting the original list. Okay, so let me run this now. Okay, so you can see now that the original list remained the same, whereas the copied list has been modified. So you can see our progression in this lesson now. So we first start with our basic data type like string. So string and integer or float, you don't have to worry about copying. If you reassign another value to a variable that is pointing to another variable before, it does not affect the original variable. When you come to data types that are modifiable, like dictionary and other data types we talk about, so if you modify another variable that is pointing to one variable initially, it is going to affect it, just like we have here. So if you modify this copied list, it's going to affect the original list. The solution to that is to use the copy method. So the copy method works perfectly fine for plain list. Okay, so it's going to create a shallow copy such that if you modify the copied list, it does not affect the original list. But when it comes to complex list structure, like a list that is containing another list, so if you want to make a deep copy, you use the deep copy function that is available in the copy module. Okay, so to use the module, you have to import it. All right, so the deep copy function is going to create a deep copy of the list, okay, such that when you modify the copied list, it does not affect the original list. So we've come a long way with list. In the next lesson, we are going to move on to another data structure called tuples, which are similar to list but come with unique features. Okay, so for that, I will see you in the next lesson.